When we hear the words biodegradable plastic, it often sounds like a perfect solution to plastic pollution. But is it really that simple? Today, let's take a closer look at one of the most common biodegradable plastics, PLA, or polylactic acid, and understand how it actually breaks down and what recycling really means. PLA is a bio-based plastic. It is usually made from renewable resources such as cornstarch or sugarcane. Because of this, it is often considered more environmentally friendly than traditional petrol-based plastics. However, bio-based does not automatically mean biodegradable in nature. PLA does not break down easily in soil, oceans, or home composting bins. Instead, it requires industrial composting conditions. Under the right conditions, high temperatures around 55 to 60 degrees Celsius, controlled humidity, and the presence of specific microorganisms, PLA can break down into lactic acid within a few months. Without these conditions, PLA behaves much like conventional plastic, remaining intact for many years. This is where misunderstandings often happen. When PLA products are thrown into regular trash or mixed with recycled plastics, they do not magically disappear. In fact, if PLA enters traditional plastic recycling streams, it can contaminate them and reduce recycling quality. So, what about recycling PLA itself? PLA can be mechanically recycled, meaning it can be melted and reshaped. But this requires separate collections and specialized facilities, which are still limited in many regions. There is also chemical recycling, where PLA is broken back down into its original building blocks, lactic acid, allowing it to be reused to make new PLA with less loss of quality. This method is promising, but not yet widely available at scale. So what is the real takeaway? PLA is not a throwaway guilt-free material. It is a tool, not a miracle. When used in the right systems with proper labeling, collection, and industrial composting or recycling infrastructure, PLA can help reduce dependence on fossil resources and lower carbon emissions in certain applications. But without those systems, its environmental benefits are often overstated. Understanding the science behind materials like PLA helps us make better decisions, not just as consumers, but as designers, businesses, and policymakers. Because sustainability is not about one perfect material, but about choosing the right material in the right place with the right system behind it.
Chemistry, making life better.